Welcome, everybody, to lesson number 36. So, today we are going to talk about scatterplots. That may be a familiar word to you. So, we spoke about data collection and we spoke about how we collect it, how we organize it in a table, analyzing it. And then at the end of that process, there's another option to graph it in a graph. So, today we're going to look at taking data from a table and putting it into a graph. And the graphs we're working with today are called scatter plots. So I wonder, do you think there's a relationship between the number of hours you study and your test mark? So that's our question. Is there a relationship between how much you study and the mark you get on a test? I think the answer is yes. I think the your test mark will reflect how much you study. So we're going to think about the idea of the relationship between variables. So when we're working with scatter plots, there's always going to be two measurable quantities. In this example, we're looking at study time and marks. And then we're going to use graphs to visualize these relationships. What is a scatter plot? It is a graph that shows the relationship between two variables using plotted points. There's two axes in the scatter plot. There's an x-axis and a y-axis. The x-axis will be the independent variable, and the y-axis will be the dependent variable. So whenever you have two variables, you want to ask yourself, what depends on what? So if we look at this example here, we have a table on our right-hand side there. It says hours studied and test score. That's our table with our data, our numbers. What depends on what? I think the test score depends on the hours studied. So when we have two variables, we're always going to ask ourselves, what depends on what? What depends on what? So at the bottom here, I'm going to write, I think the test score depends on how much you study. Therefore, our test score is our dependent variable. So that's our y. And therefore, our hours studied is our x, and that is our independent variable. So now that we figured out our variables, we can start making our graph. So the first thing, we're going to be using that graph paper on our left-hand side. And the first thing we want to do is organize our graph, make sure it has a title, make sure our axes are labeled, and then we can plot. So our title can be, let's keep it simple. We'll go test scores and study hours. That's our title. And when we are working with our graphs, we always want to stay organized. We want it to look neat and tidy. So I would, if I was working on paper, I would take a ruler and I would do a nice straight line and underline my title. Now on our graph, we're going to have a 0 here. So we remember that our bottom line on our graph is our x. And this vertical line on this side will be our y. So now we have to label our axes. So we decided that our test score is our y. So let's label that side. Our y is our test score. And again, we're staying neat and tidy with our labels and our titles. And then our hours studied. Hours is our independent variable. Hours studied. All right. Now we can fill in our numbers. So hours studied, we have 1, 2, 3, 4, 5, 6. As you see in the table, it only goes up to 5. So we'll go up to 5 to make sure that that's there. And then on our Y, our numbers are 50, 55, 65, 70, 80. Okay. So on our graph here, let's go up by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so let's go through some things. We have a title, we have our axes labeled, we have our numbers on our graph, we have proportionate scales, and now we can plot our plots. So if we study for 1 hour, or if a student, studied for 1 hour, they got a 50%. So we will go 1 hour. So go to the 1 on your x axis, and your y is 50. So we'll go up to 50, and then we do a little dot. We do a plot. So this here is 150. That's how we would write it in the ordered pair to plot it. Okay, our next one will be 2 hours, and the score was 55. 2, and then we will go 55 would be right there in the middle. 3 would be 65. 3, 65. Again, I'm being precise when I am plotting my dots on my graph. I'm staying organized. 4 hours resulted in a 70. And 5 hours resulted in an 80. 5 hours resulted in an 80. Okay. So after we have now plotted our plots, that is it. We are done our scatter plot. So our scatter plot is not like a bar graph or a line graph. We don't connect our dots. We will be visiting the idea of a line of best fit, but that's not like connect the dots where all the dots are connected. That's going to be a line that goes through the majority of the dots. For a graph without the line of best fit, with just a scatter plot, this is what it will look like. It will look like the axes labeled with the title and dots on a graph. Some reminders when we're graphing. Did we have proper scale? So the numbers we chose on our y and x axes, are they properly to scale? Yes, we chose going up by tens, we chose going up by ones, and all of our data fit. So yes, we chose the right scale. We labeled our axes and we plotted our ordered pairs. We plotted all the dots, all the data. So with the scatter plots, there will be different trends. So there's different types of relationships when we can go in after and analyze this graph. There are 4 we're going to talk about. The first is a positive relationship. That means as x goes up, as x increases, y increases, and there's an upward trend. The next is a negative relationship. As X increases, Y decreases, and that will give us a downward trend. Number 3 is no relationship, which means there's no clear pattern. No relationship will just look like a bunch of dots everywhere, and there's no real direction. Number 4 is a cluster and outlier. So cluster would be all the dots are really close together in one area. And an outlier would be maybe all the dots are in one area, but then you'll have one random dot over here. And that one random dot is the outlier. If you look at this diagram, this one over here is a strong positive correlation that's going upwards. And all the dots pretty much are together on the same line. Weak positive. So it's still going up, but it's weak because the dots are a little bit more farther apart. It's not as tight knit. If it's tight, it's strong. If it's a little more loose, it's weak. Now this will give us a downward trend. That means it's a negative correlation. Downward is negative. And it's still a strong relationship though, because the dots are closer together. It's a tighter relationship. This is a downward relationship. It's a negative correlation, but the dots are more spread out. So it's a weak negative correlation. This one here, it's a downward, so it's negative, but it's moderate. See how the dots, they're kind of together, but they're a little bit spread out. They're not as spread as a weak, but they're not as tight as strong. So we'll call it a moderate negative. This one here, this is where there's no correlation because the dots are just everywhere. There's no real direction, and that's how we know there's no relationship. When we go to describe these relationships, so how can we describe these relationships? We write sentences about scatterplots using sentence frames like the ones below. So these sentence structures are examples of what you could say in writing to describe a graph. There is a positive relationship between blank and blank. There is, as blank increases, blank tends to blank. So as number of hours studied increases, the test score tends to increase. That sentence can be something you write on an assessment when it's asked to explain your analysis or explain the relationship. The data shows a weak, moderate, strong, whatever you see, relationship. There is an outlier at approximately, and then you would say where that outlier is. There is an outlier at 580. That's not our case, that's just an example. So we have another data set. Let's practice. Here we have temperature outside, so the outdoor temperature, and ice cream sales. So we're going to ask ourselves, what depends on what? So I think sales depends on the temperature. If it's a hotter day outside, I think more people will go get ice cream, which will then result in higher ice cream sales. If it's colder outside, I don't think people will be going for ice cream. So therefore, there will be less ice cream sales. That's my opinion. So therefore, sales will be our Y. Sales is what is the dependent variable. Sales depend on the temperature. And therefore, our temperature is our X. So our temperature is our independent variable. So create a scatter plot. We know we need a title, we need to label our axes, we need to choose a proper scale, and then plot our dots. So let's think of a title. Let's go temperature, and ice cream sales. So I ran out of room there, but on your paper, you would want to, you know what, actually, let me move it over. Ice cream sales and temperature. Then we will underline it. We have our X, we have our Y. We always put the little 0 in the corner. Now let's label our axes. So X is temperature, and that's going to be in Celsius. And on our Y, it's our ice cream sales. And that's in dollars. Okay, so now we have our axes labeled. We have a title. Now let's choose our proper scales. So we're going to choose our numbers. How are we going to write our numbers on our graph? So here we have temperature. I see 15 to 30. Those are our numbers, 15, 18, 22, 25, 30. I think I'm going to go up by 5, starting at 10, 15, 20, 25, 30, 35, 40. And our ice cream sales, 200 to 500, 200, 250, 320, 400, 500. So the scale I think we should start at is using our hundreds. So 100, maybe I'll go by 50. 250, 350. Okay, to 500. Now that we have our scales, we can plot our dots. So 15, 200. So let's go 15. When it's 15 degrees outside, they made $200. 15 degrees, $200. Our dot goes right there. Okay. 18 degrees made $250. 18 degrees made $250. I think that would be there. 22 degrees made 320. 22 made 320. 25 degrees made 400. And 30 degrees made $500. And that is our scatter plot. So now knowing what we know about relationships, we can look at our graph and see a relationship. We see that it's going upwards. We see that as X goes up, Y goes up. So that's a positive correlation, a positive relationship. And we see that our dots are fairly close together. So I would say that's a strong relationship. So when we go to ask our questions, now we answer them. What is our relationship? It is positive. It's a positive relationship. The trend, I would say it's a strong, positive. And that word correlation is the relationship. Correlation. And is it strong or weak? Strong. And there you go. So that is our lesson on scatter plots. Next lesson, we're going to be looking at our line of best fit. That's when you're going to see the line put in the middle of the dots. And that's another way just to get a better idea of the trend, just a better idea of what relationship looks like. And there will be a student handout to match this lesson where you will create your own scatter plots. Okay, good luck, and I will see you next lesson.